Okay, hi everyone, welcome back to this video series on the data center. Practice example hash 4b255.255.254.0/23.172.16.0.0 equals network address 255.255.254 equals subnet mask subnets 27 equals 128 host 29 minus 2 510 valid subnets 256 minus 254 equals 202.468 etc. up to 254. Broadcast address for each subnet valid hosts. The following table shows the first 5 subnets, valid hosts and broadcast addresses in a class B 255.255.254.0 mask subnet 0.0, 210, 410, 610, 810, first host 01201, 401, 601, 801, last host 1.254, 3.254, 5.254, 7.254, 9.254, broadcast 1.255, 3.255, 5.255, 7.255, 9.255. Practice example 5b 255.255.255.0/24. Contrary to popular belief, 255.255.255.0 used with a class B network address is not called a class B network with a class C subnet mask. It's amazing how many people see this mask used in a class B network and think it's a class C subnet mask. This is a class B subnet mask with 8 bits of subnetting. It's logically different from a class C mask. Subnetting this address is fairly simple. 172.16.0.0 equals network address. 255.255.255.0 equals subnet mask. Subnets 28 equals 256. Hosts 2 8 minus 2 equals 254. Valid subnets 256 minus 255 equals 1, 0, 1, 2, 3, etc. all the way up to 255. Broadcast address for each number of valid hosts. The following table shows the first 4 and last 2 subnets to valid hosts and the broadcast addresses in a class B 255.255.255.0 mask. Subnet 0.0, 1.0, 2.0, 3.0, 254.0, 255.0, first host 0.1, 1.1, 2.1, 3.1, 254.1, 255.1, last host 0.254, 1.254, 2.254, 3.254, 254.254, 255.254, broadcast 0.255, 1.255, 2.255, 3.255, 254.255, 255.255. Practice example hash 6b 255.255.255.128/25. This is one of the hardest subnet masks you can play with, and worse, it actually is really good subnet to use in production because it creates over 500 subnets with 126 hosts for each subnet. A nice mixture, so don't skip over it. 172.16.0.0 equals network address. 255.255.255.128 equals subnet mask. Subnets 29 equals 512. Host 27 minus 2 equals 126. Valid subnets. Okay, now for the tricky part. 256 minus 255 equals 1, 0, 1, 2, 3, etc. for the third octet, but you can't forget the 1 subnet bit used in the fourth octet. Remember when I showed you how to figure one subnet bit with a class C mask? You configure this the same way. Now you know why I showed you the 1-bit subnet mask in Class C section. To make this part easier, you actually get 2 subnets for each third octet value, hence the 512 subnets. For example, if the third octet is showing subnet 3, the 2 subnets would actually be 3.0 and 3.0.128. Broadcast address for each subnet valid host. The following table shows how you create subnets, valid host and broadcast addresses using the Class B 255.255.255.128 subnet mask. The first 8 subnets are shown, and then the last 2 subnets, subnet 0.0, 0.128, 101.128, 2.0, 2.128, 3.0, 3.128, 255.0, 255.128, first host 01, 0129, 1.1, 1.129, 201, 2.129, 301, 30129, 255.1, 255.129, last host 0126, 0.254, 1.126, 1.254, 2.126, 2.254, 3.126, 3.254, 255.126, 255.254, broadcast 0.127, 0.255, 1.127, 1.255, 2.127, 2.255, 3.127, 3.255, 255.127, 255.255. Practice example #7b 255.255.192/26. Now this is where Class B subnetting gets easy, since the third octet has a 255 in the mask section. Whatever number is listed in the third octet is a subnet number. However, now that we have a subnet number in the 4th octet, we can subnet the 3rd octet just as we did with Class C subnetting. Let's try it out. 172.16.0.0 equals network address. 255.255.255.192 equals subnet mask. Subnets 210 equals 1024. Host 26 minus 2 equals 62. Valid subnets 256 minus 192 equals 64. The subnets are shown in the following table. Do these numbers look familiar? Broadcast address for each subnet, valid hosts. The following table shows the first 8 subnet ranges, valid hosts and broadcast addresses. Subnet 0.0, 0.64, 0.128, 0.192, 1.0, 1.64, 1.128, 1.192, first host 0.1, 0.65, 0.129, 0.193, 1.1, 1.165, 1.129, 1.193, last host 0.60, 0.62, 0.126, 0.190, 0.254, 10.62, 1.126, 1.190, 1.254, broadcast 0.63, 1.127, 0.191, 0.255, 1.63, 1.127, 1.191, 1.255. Notice that for each subnet value in the 3rd octet, you get subnets 0, 64, 128 and 192 in the 4th octet. Practice example #8b 255.255.255.244/27. This is done the same way as the preceding subnet mask, except that we just have more subnets and fewer hosts per subnet available. 172.16.0.0 equals network address. 255.255.255.2 224 equals subnet mask. Subnets 211 equals 248. Hosts 25 minus 2 equals 30. Valid subnets 256 minus 224 equals 32.0.32.64 128 160 192 224. Broadcast address for each subnet valid host. The following table shows the first 8 subnets. Subnet 0.0, 0.32, 0.64, 0.96, 0.128, 0.160, 0.192, 0.224. First host 0.1, 0.33, 0.65, 0.97, 0.129, 0.161, 0.193, 0.225. Last host 0.30, 0.62, 0.94, 0.126, 0.158, 0.190, 0.222, 0.254. Broadcast 0.31, 0.63, 0.95, 0.127, 0.159, 0.191, 0.223, 0.255. The next table shows the last 8 subnets. First subnet 255.0, 255.32, 255.64, 255.96, 255.128, 255.160, 255.192, 255.224. First host 255.1, 255.33, 255.65, 255.97, 255.129, 255.161, 255.193, 255.255. Last host 255.30, 255.62, 255.94, 255.126, 255.158, 255.190, 255.222, 255.254. Broadcast 255.31, 255.63, 255.95, 255.127, 255.159, 255.191, 255.223, 255.255. Subnetting in your head Class B addresses. Subnet Class B addresses in our head is actually easier than writing it out. Let me show you how. Question: what subnet and broadcast address is the IP address 127.16.10.33, 255.255.255.224/27, a member of? Answer: the interesting octet. The octet where we count the block size is the 4th octet. 256 minus 224 equals 32.32 plus 32 equals 64. Bingo. 33 is between 32 and 64. However, remember that the 3rd octet is considered part of the subnet, so the answer would be 10.32. The broadcast is 10.63, since 10.64 is the subnet. Is the next subnet. Question: what subnet and broadcast address is the IP address 172.16.66.10, 255.255.192.0/18, a member of? Answer: the interesting octet is the 3rd octet instead of the 4th octet. 256 minus 192 equals 64. 0.64, 128. The subnet is 172.16.64.0. The broadcast must be 172.16.127.255, since 128.0 is the next subnet. Question: what subnet and broadcast address is the IP address 172.16.50.10, 255.255.224.0/19, a member of? Answer: 256 minus 224 equals 0. 3264. Remember, we always start counting at 0. The subnet is 172.16.32.0 and the broadcast must be 172.16.63.2 255 since 64.0 is the next subnet. Question: what subnet and broadcast address is the IP address 172.16.46.255.255.240.0/20 member of? Answer: 256 minus 240 equals 16. The third octet is interesting to us: 0, 16, 32, 48. This subnet address must be in the 172.16.32.0 subnet, and the broadcast must be 172.16.47.255 since 48.0 is the next subnet. So yes, 172.16.46.255 is a valid host. Question: what subnet and broadcast address is 255.255.255.252/30 a member of? Answer: where is the interesting octet? 256 minus 252 equals 4.0.4.8.1216 in the fourth octet. The subnet is 172.16.45.12 with a broadcast of 172.16.45.15 because the next subnet is 172.16.45.16. Question: what is the subnet and broadcast address of the host 172.16.88.255/20? Answer: what is /20? If you can't answer this, you can't answer this question. You can. A /20 is 255.255.240.0, which gives us a block size of 16 in the third octet, and since no subnet bits are on in the fourth octet, the answer is always 0 and 255 in the fourth octet. 0.16, 32, 48, 64, 80, 96. Bingo. 88 is between 80 and 96, and the subnet is 80.0, and the broadcast address is 95.255. Question: a router receives a packet on an interface with a destination address of 172.16.46.191/26. What will the router do with this packet? Answer: discard it. Do you know why? 172.16.46.191.26 is a 255.255.255.192 mask, which gives us a block size of 64. Our subnets are often 0, 64, 128, 192 and 1.191 is the broadcast address of the 128 subnet, so a router by default will discard any broadcast packets. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.